Welcome back, guys, to the third video in the problem-solving mini-lecture series using mass, moles, and molecules conversion factors. In this video, we are going to look at an example problem that requires us to convert between moles of a molecule and the mass given to us in grams of that sample. All right? Following the same approach we outlined in this previous video, I want you guys to start this problem the same way by using first step of just basically laying out the pathway we're going to follow. In this problem, we're asked to figure out how many moles of a substance, right, S2F10 in this case, are contained in a pure 128 gram sample of the substance. So we're going to be starting in this case with grams. We're told that we have a certain mass in units of grams, and we want to convert that value into the number of moles. All right? So we need to go between grams and moles. So again, without plugging in numbers, we need to figure out which one of our conversion factors over here allows us to perform this mass to moles conversion. Coming over to our list, we're going to start at the top. Avogadro's number that we used in the previous video, well, that's not going to help us in this one. Converting between moles and number of individual atoms or molecules isn't required by the problem. So then we're going to come down to our next conversion factor, molar mass. Molar mass tells us the number of moles of a substance, the number of grams of a substance in a given mole, all right, and in 1 mole of whatever compound we're dealing with. So that does in fact match what we need here. So what we're going to do is we're going to make a little note. We're going to say, okay, if I want to carry out this conversion factor, I'm going to need the molar mass. Now, the molar mass, of course, depends on what substance you're working with. In this case, we have the chemical compound S2F10. So a compound comprised of 2 sulfur atoms and 10 fluorine atoms. So we're going to have to go to the periodic table, look at the molar mass of sulfur, multiply it by 2, and add that to the molar mass of fluorine multiplied by 10. If you carry that out, we will find that 1 mole of S2F10 weighs approximately 254.1 grams. Okay? Or 1 mole S2F10 equals 2.54.1 grams of S2F10. Okay? So now we have the conversion factor we need, and we know where we're starting, we know where we're ending up, so now we're all set to go ahead and do our final step. Step 2 here. So step 2, we're going to start off with our mass, but this time we're going to plug in the actual numerical value, 128 grams. And notice I'm always careful here to write on not just grams, but grams of what, right? So grams of S2F10 in this case. Now, we need to convert this grams, this amount in grams, ultimately to some amount in moles. Okay. So following the same sort of procedure that I recommended in the last video, we need to set up our molar mass conversion factor such that the grams are being canceled out and we're being left in units of moles, which means we're going to want the conversion factor of grams down here in the bottom. Okay. And we're going to want our mole conversion factor up top. Now, looking at our conversion factor that we found in the previous step, we can plug in the actual numerical values. 1 mole of S2F10 is equal to 254.1 grams of S2F10. All right, grams cancels out. We're left with units of moles. And if we plug that into the calculator, you should get a value of approximately 0.504 moles of S2F10. So that concludes this video. Now, in the next video, we're going to be exploring, an application of the molecular formula as a conversion factor to convert between numbers of atoms and numbers of molecules.